Okay. All right. Okay, let's start, huh? Okay, so welcome everyone. So thank you everyone for joining today's lesson. Now, some of you are my students, right? In our wiki class. Some of you are not. So it doesn't matter, right? Welcome. And I'm very happy that, I expected to have maybe 20 students in the class today. But now I'm having about 143 of you. Thank you very much for joining. I know it's a public holiday. You guys want to sleep, right? Any of you wants to sleep, and then your parents say, "Hey, wake up, wake up! You need to attend Mr. Young's session." You can see so many of you raise your hand, and you guys are the Muslim student. You guys are fasting somehow, correct or not? You early in the morning must wake up. Must listen to Mr. Young talk, right? Okay, don't worry. So today it is going to be a very interesting lesson. I hope that it is beneficial because of PSLE, right? So today I'm going to discuss last year's PSLE. That means the latest PSLE question, open-ended question, where many students have problems in, right? And after analyzing last year's paper, I can say that the open-ended question is not too easy, not too difficult, right? There are some very challenging questions, right? So it is likely that you will see similar question this year as well, right? So that's why I want to share with you guys the answering technique that you can apply, okay, and the kind of question that you can expect in the PSLE. Okay, so today I'm going to focus on the open-ended question, physical science. Okay, like I mentioned earlier, in the PSLE paper, half is physical science, half is life sciences. Life sciences has to do with living things, from the word life, living things, right? So what are life sciences topics? Living things includes plants as well as animals as well as human. Okay, so we learn about plant reproduction, we learn about human reproduction, digestive system, about cells, respiratory system, circulatory system. All those involving living things is under life sciences. Now, physical science is the other half. So 50% of PSLE science, it is physical science. Physical science deals with, simply put, non-living things. Okay, so non-living things, right? For example, the topic on heat, the topic on light, the topic on magnets, forces, energy, right? All these are life physical sciences topics. All right, so today I'm going to discuss the open-ended question, the physical science question, right? And there are 5 questions in the PSA. Those of you who have your PSA booklet, you can refer to. They are from question 35 onwards. Okay, so today, those of you who do not have the paper, don't worry, just sit back and relax. Now, I need you guys to have your notes. Sorry, not your notes, a notebook or a piece of paper at least, foolscap paper and writing material. So any kind of notes that you want to take, that you benefit from this lesson, please write down. Okay, so that you can remember better. Now, let's take a look at the very first question. Okay, this is what we call an application question. Okay, so Ali sprayed some hand sanitizer on his hand. State why Ali's hand become dry very quickly. That is part A, yeah? It's a 1-mark question. Part B, Ali sprayed hand sanitizer on his hand again and blew on it. Explain why his hand felt colder than before. Okay, so you can see all of you have used hand sanitizer before, right? Correct or not? Especially during the COVID period. All of us, we bring hand sanitizer, right? Bring to school, bring to everywhere, right? So that we keep our hand free from the virus, right? Okay, now let's analyze this question. Now, when you guys are answering science question, you need to read very carefully, right? And you can use the underlining technique, right? Or you can highlight the keywords. Now, it's very important that you highlight the keywords or understand or take note of the keywords in the question itself. Okay, I'm not talking about keywords in the answer, from the question itself. Okay, so first important clues in the question, Ali sprayed hand sanitizer. Now, what is hand sanitizer? Everybody will know. Hand, right? You know, spray on the hand. So part A, they ask you state why Ali's hand become dry very quickly. Okay, so that is the you need to state why the hand become dry very quickly, right? So this is for part A. Now part B, Ali sprayed hand sanitizer on his hand again and blew on it. So blow, you all know blow, right? Like, explain, right? Why his hand felt even colder than before. So this is, you can see, explain. Explain means you need to elaborate, you need to give a reasoning of what is happening, right? You need to insert scientific concept. Okay, so you can see the marks is also a 2-mark question. So your answer must be very elaborate and must be accurate. Okay, so let's talk about the concept itself. What topic? Before you answer the question, you need to ask yourself, what topic are they exactly asking in the question? Because you guys learn from P3 to P6, right? In your PSLE, P3 to P6 topic will be covered. And there's many topics. There are many topics, maybe about 20 to 30 topics, right? From P3 all the way to P6. Okay, so you must be able to identify the correct topic. So here is on the topic of P5, water. The change of state of water, right? You guys remember in P5, back in P5, you guys learn about water. So there are 5 change of state, right? Boiling, evaporation, melting, freezing, and condensation, right? The 5 change of state. So you need to be able to identify the correct process. Okay. And the concept, right, for the first part here is evaporation. Okay, the concept is evaporation, not condensation, not boiling, right? Not melting. So this is on evaporation. And you need to understand what does evaporation means, right? So if you recall very quickly, right, evaporation is a change of state from liquid to gas. And this involves heat gain, right? So this is, you need to be able to recall the concept. And for part B, right? For part B, now let's recall. Remember on the topic of water, you guys learn about factors affecting the rate of evaporation, right? There are 3 factors in your syllabus that you need to know that affects the rate of evaporation. Number 1, the temperature of the surrounding, right? Secondly, the exposed surface area of water. And thirdly is the presence of wind. So in this question, you can see here, Ali blew on it. So can you link with factors affecting rate of evaporation, right? So the presence of wind increased the rate of evaporation, right? So you recall the factors of, one of the factor of evaporation affecting rate of evaporation is presence of wind. So the presence of wind, the faster the wind blow, the faster is the rate of evaporation. Okay. Somebody telling me to go slower. Okay, no problem. Right, I'm just going through the concept. I've not gone through the answer yet. So don't worry. This is not the answer yet. This is just going through the concept. All right. I'm just going through the thinking process. That means before you guys answer the question, you must go through a certain thinking process, right? Before you can answer the question. Okay. So all of you understand? These are the concepts involved in this question. Okay, now let's answer part A here. Right? So state why Ali's hand become dry very quickly. Now, hand sanitizer, we know that why it dries very quickly, because it has a lower boiling point than water, right? Because it contains alcohol actually inside, right? So it dries, right? When you put hand sanitizer on your hand, you can feel it becomes, your hand becomes cold, right? So what's the reason your hand become cold? Because the hand sanitizer evaporate very quickly. Why evaporate very quickly as compared to water? Because it has a lower boiling point than water, right? So that is the first part of the answer. The hand sanitizer has a lower boiling point, and hence it gain heat and evaporate very quickly, changing state from liquid to gas, causing Ali's hand to become dry very quickly. Okay, so that's the answer for part A. Right? So I repeat, hand sanitizer has a low boiling point. Now, the part that I underline, these are the keywords. Okay, the hand sanitizer has a low boiling point. Now, let's recall, what does evaporation means? Evaporation is a change of state, right? From liquid state to gas state. Right? So evaporation is a change of state from liquid to gas. So this is part of the answer here, and it must gain heat, right? So evaporation involves gaining heat. Okay, so that's why Ali's hand become dry very quickly, right? Okay, Abdul Matin say, what happened if we do not put low boiling point? I think they will also accept, right? This low boiling point, all right, if you do not put low boiling point, I believe because it is only a 1 mark question, if you just say you involve evaporate, gain heat from liquid to gas, you will still get the full 1 mark, okay? Right? So, of course, in my answer, I try to be as comprehensive as possible. So, if you put low boiling point, that's the best. Right? Because it's true, right? Hand sanitizer is made of alcohol, which has a lower boiling point than water. That's why it evaporates quicker compared to water. Okay, part B. Ali sprayed hand sanitizer on his hand and blew on it. Now, we are going to bring another concept. When he blew on it, what happened? It increased the rate of evaporation. Okay. So we know from first part that the hand sanitizer evaporate, right? When it evaporates, that's why our hand feel cold. Because the hand sanitizer gain heat. It gains heat from where? From our hand. So when Ali sprayed, blew on it, okay, Ali's hand loses heat to the hand sanitizer as it was evaporating, right? So we must know. When the water or when the hand sanitizer is evaporating, Ali's hand loses heat. That's why you feel cold. So the second part is that when he blew on it, what happened? The rate of evaporation increased. The rate of evaporation increased. Okay, so when rate of evaporation increase, what does it mean? It means that the liquid will gain heat even faster. And Ali's hand will lose it even faster, right? So that's why he feel even colder than before. Okay? All right, understand everyone? Can, Okay, good. So how you find this question? Doable or not if it comes out in the PSLE? Aisha? Easy, Can, Okay, good. Okay, those of you who wants to ask question, I repeat, I may not be able to answer because of time as well as there's quite a number of you. So if you want to ask any question, just type in the group chat, okay? All right, let's move on to the next question. Next question, All right. Okay. Thomas carried out an experiment with a toy boat. He turned the propeller to twist the rubber band before releasing the boat into a bathtub filled with water. He measured the distance moved by the boat, so there was no wind during the experiment. So this is an experiment type question. Okay, let's analyze the keywords in the question. Okay, now remember, those of you in my class, each time when we see any experiment type question, these are some of the questions that we must ask ourselves. Right? Number one, what is the aim of the experiment? Correct, right? Secondly, what is the change variable? And we remember, change variable, there can only be one change variable in an experiment. Otherwise, it is not a fair test. Right? And change variable is also known as the test variable. Okay? So there can only be one change variable in any experiment. And you also have to identify the fixed variables. Right? What are the fixed variables? Now, other than change variable, everything else must be fixed. Other than fixed variable, sometimes it's also called constant variable. So it's the same. Okay, the next variable that you need to know is what we call the measured variable, right? Or measured variable is also known as a result of the experiment. Okay, and the next thing that you need to know when you see any experiment question, you need to be able to analyze the results of the experiment. Okay, so these are the process that you have to go through your mind when you see any experiment type question. Now, this is an experiment type question on the topic of energy conversion, right? Some of you have just learned the topic of energy conversion is a P6 topic. Okay, now let's analyze here. If you look carefully at this question, the aim of the experiment is not clearly given, right? So they say that Thomas carried on an experiment with a toy boat. He turned the propeller to twist the rubber band before releasing the boat into a bathtub filled with water. he measured the distance moved by the water. So there's no clear aim of the experiment, right? But you can identify the change variable. So what is the change variable? The change variable is the number of turns of the propeller. So he turned the propeller. Can you imagine he turned the propeller, right? So for the first test, it is he turned 10 times. And then after that, turn 20 times. And then turn 30 times. And the measured variable is the distance moved by the toy boat, right? So you can see here, he measured the distance moved. First try for 10 propeller, 15, and then the second try 14. Okay, first question, why two tries? Right? Why two tries? Even though it's not part of the question here, but you must know, right? In any experiment, usually you need to repeat the experiment. Why? This to ensure the results is reliable, right? So in this particular experiment, it is repeated once, right? First try, second, sometimes 3 times. Okay, so this to ensure the reliability of the results. But they did not ask you, but never mind. Sometimes, they may ask you in other questions. Okay, so analyze the results. So what does the result show? So you can see that as the number of propeller turns, the number of turns of propeller increase, the distance moved by the boat also increase. So this is true for both tries. Okay, so that is your observation, right? So we have not answered the question yet. This is just by the process skills involved, right? Those of you in my class, you know that I've given you template and we have discussed this quite in depth. When you see any kind of experiment question, these are the questions that you must ask yourself before you start answering the question. Okay, now let's answer the question itself. Question number 1, they ask you, state how the number of turns of the propeller affected the distance moved by the boat. Okay, so this is a typical relationship type question. You guys remember, right? Relationship type question, very straightforward. Okay, so that means you need to state how the number of turns of the propeller affect the distance moved by the boat. Okay, so please use the terms that they use in the question itself. Do not paraphrase or use other phrases, right? So because it could mean differently, All right, and then part B, fill in the boxes to show the energy conversion. Okay, to show the energy conversion. So recall, right? You guys learned in P6, right? The topic of energy conversion. In rubber band, what is the energy conversion in rubber band? Right? In the propeller, what is the type of energy? Okay, and then the boat, what is the type of energy? So you must be able to identify the correct type of energy and be able to state the energy conversion from what energy to another energy. Right? Remember, we recall that energy can neither be created nor destroyed, but it can only be converted from one form to another. Okay, you guys learned this concept when you studied the topic on energy conversion. Then part C, suggest a reason. Now part C is the challenging part. Suggest a reason why the distance moved for both tries are different for 20 turns of propeller when Thomas released the boat at the same edge of the bathtub. So basically they ask you, they're asking you this, right? You see the 20 turns, right? Why is it, first try, 24.6 centimeter. And then the second try, 26.3. Right? So they're asking you this. Why is there a difference? And it's a 1-mark question. So they ask you to suggest a reason. Right? Okay, so how the clues, remember I mentioned many times, the clues for part C or the later part, you can always look at the earlier part for the clue. So you need to link to part B, to see the effects of energy change to the overall conversion equation. Okay, so this is analysis of the question. All right, so next I'm going to move on to answer the question itself. Okay, so part A, state how the number of propellers, turns of propeller affected the distance moved by the boat. Okay, so as the number of turns of the propeller increase, the distance moved by the boat also increase. Easy peasy, 1-mark question, right? Easy peasy, you can score 1 mark. So you can see here, number of propellers, you can see as the number of propellers increase, the distance moved also increase. Easy peasy, okay? So easy, 1 mark. Now part B is also quite straightforward. It's a 2-mark question, but you just need to be able to identify the correct type of energy. Okay, rubber band, what energy? Elastic potential energy, right? Rubber band, you guys learn rubber band, elastic potential energy. Now, if you guys put potential energy also no problem, right? But elastic potential energy is more precise. In the propeller, so they box for you, so you can see plus here. Propeller, kinetic energy. Why kinetic energy? Because it is moving, right? Anything that is moving has kinetic energy. And then you need to think, this one maybe a little bit, not so straightforward. Sound energy. How come there's sound energy? Right? Because when the propeller is moving, right, there will be some form of sound energy. Even though it may be very little, but there's some form of sound energy. Right? And then the boat, when the boat is moving, again, there is kinetic energy. All right? Raha, yes. Yeah, you can remove that. Okay, Daniel asked, heat energy. So instead of sound, if you put heat energy, I think the examiner will also accept. Right? Can also, but I think sound energy is more straightforward. Right? It's more clear, right? Because we can hear. We may not be able to feel. Now, it doesn't mean heat energy, it must be hot. Heat energy is you may not be able to feel with your hand, right? But heat is still present. Okay? Now, let's move on to part. Okay, some of you ask, teacher, can I answer about force? No, this is not a question on force, right? This is a question on energy. Don't mix up the topic on force and energy. Many students, they mix up the topic on force of energy. There's nothing to do with frictional force here, right? They are not asking you about frictional force. They ask you, show the energy conversion, right? So don't put about friction, Okay, now let's take a look at part C. Suggest a reason why the distance moved for both tries are different for 20 turns. Okay, so you can see here, they're asking you why for the first try, 24.6, and then for the second try, 26.3. Several reasons. Because let's link part C to part B, right? So you can see here in the second try, the distance move is more, right? So distance move more means what? That means the boat has more kinetic energy. So you can see I'm linking part C to part B. Right? Sometimes it's not easy to answer part C, but the clue is always in the earlier part. So you can see in the second try, right? The boat move a further distance, right? Further distance means what? The boat has more kinetic energy. So why does the boat has more kinetic energy? So it could be that it has more sound energy or the propeller move faster. Right? So the propeller move faster, right? Because when the propeller move faster, then it will be the boat will also move faster. Now, what can cause the propeller to move faster? Because there is more elastic potential energy. So you can see here the answer to part C, you have to link back to the number of turns in the rubber band, right? Which is the elastic potential energy. So this gives you a very, very important clue. Very subtle, right? So it gives you a clue how to answer part C. Okay? So the rubber band may not have been twisted to the same extent, even though the propeller is turned the same number of times, right? So here, how they stretch the rubber band is by turning the propeller. So when you turn the propeller 20 times, does it mean that the rubber band is stretched the same amount for the first turn and the second turn? May not be, right? There could be slight difference, right? So that slight difference caused the distance move by the boat to be different. Okay, not easy. So I think this is a little bit not easy, but the clue you can see here is in part B. All right. Okay, any questions, class? Those who got any question, please type your answer, your question in the group chat. Okay, if I say if there's no wind, which wind is heat energy? Right? So there's no wind, you're right. There's no wind here involved, right? Okay, all right. Let's move on to the next question. Okay, let's move on to this question. Okay, let me read for you guys. Okay, Meme cooked some vegetables using oil F in a heated pan. She measured the temperature of the pan before adding the vegetables until after the pan was washed. Her results are shown below. So this is, I wouldn't say it's an experiment question, right? But more of application question, right? But they communicate the findings in the form of a graph. So you need to be able to interpret the graph. Now let's analyze the question. Okay, what process skills? Number one, if you look at part A and part B, you must have the ability to interpret graph and to communicate your findings in an experiment or in a situation. Okay, so the ability to interpret graph is very important. It's part and parcel of your science syllabus, right? Even though if you look at this question, you will not be able to see any of this question in your textbook, right? Because why? This is an application type question, right? Where you need to understand, be able to communicate your findings in any science experiment or understand graph. Okay, so this is, you guys would know by now, interpreting graph is a very common part in the PSLE science. Okay, and secondly, the concept. Okay, what concept? Is a concept of heat gain, right? You must know that matter gain heat when heated and lose heat when cooled, right? You guys learned this back in primary 4 under the topic of heat and temperature, right? You know that matter gain heat when heated and lose heat when cooled. Okay, so in this particular experiment, this particular example here, Mei cook vegetables on a heated pan. So when she turned on the temperature, right, turn on the heat on the pan, so you can see that over time the temperature increases. Okay, so you can see, let's analyze the graph. So the horizontal axis here represents the time, and the vertical axis here represents the temperature of the pan. Okay, right? Okay, so, and then another thing that you must know that in this question, it tests you on the concept of heat transfer. Okay, let's recall, how does heat transfer? Heat travels from a region of higher temperature to a cooler temperature until it reaches the same temperature, right? Remember that? You guys learned this back in primary 4. Okay, heat travels from region of higher temperature to low temperature until it reaches the same temperature. So when the temperature is different, is the same, then there will not be any more heat transfer. Okay? Okay, and then for part C, if you look at part C here, after cooking, she poured the hot oil into the sink. Oil F has a melting point of 40 degrees Celsius. So now we bring into the P5 topic on melting. All right, you guys learn under the topic of water. Melting is one of the process of change of state. What is melting? It's a change of state from solid state to liquid state when the solid gain heat, right? So this is a combination of a P4 topic on heat as well as a P5 topic on melting, right? Okay, so let's take a look at the question itself. First question, state the room temperature. State the room temperature. Now, can you guys type in the group chat? What do you think is the room temperature in this graph based on understanding of this graph? Okay, can you guys type in the group chat? What do you think is the room temperature? Many of you put 20. Many of you put 20. Some of you put 40. Some of you put 25. Okay. Now, some of you put 0, 28. Okay. The answer is 30 degrees Celsius. 30 degrees Celsius. Okay, why? Okay, so for you to understand this, you must understand what is going on in the graph. Okay, let me explain. Let me explain. Okay, so you can see here, the horizontal axis represents the time, right? So Mei was cooking, right? Mei was cooking the vegetable. So he heated the pan. She heated the pan. So at first, the pan was, she measured the, okay, you see, she measured the temperature of the pan before adding the vegetable, but after the pan was washed. Okay, Mei cooked some vegetables using oil F on a heated pan. She measured the temperature of the pan before heating the vegetables. Okay, so that means she started to measure the temperature of the pan before adding the vegetable. So they did not say from the room temperature. So this is where she started the measuring process. At that point of time, the temperature of the pan is already 40 degrees Celsius. Okay, so you need to read the question very carefully here, very tricky. Yeah, that's why some of you put 40 as the answer, right? But it's not. So this is where she started measuring, right? Because they say that she measured the temperature of the pan before adding the vegetable. Okay, so then the temperature rises, right? Because the pan is getting heated up, right? Until a peak of 160 degrees Celsius. So when the pan reached 160 degrees Celsius, she added the vegetables, right? Because the vegetable is cooler than the pan, right? So that's why there's a drop of temperature. The temperature of the pan drops slightly because you're adding something cold onto something hot, right? So the overall effect is that it decreases the temperature of the pan, but it's just momentarily. And then after it goes up again until it reaches the maximum of 160 degrees. Okay, so what happened here? How come suddenly there's a drop? So this is where she complete cooking the vegetables, right? Because they say that she measured the temperature of the pan before adding the vegetable until after the pan was washed. So that means she switched off. This is the point where she turned off the heat and then she start to wash the pan. So when she washed the pan, the temperature goes down, right? The temperature decreases because the pan loses heat, right? Loses heat to the coolest surrounding air until the end, where the temperature became constant at this temperature. So if we draw a dotted line on the side here, you can see here between 20 and 40 degrees Celsius, what is 30 degrees Celsius? So this is the room temperature. This is the room temperature. Okay? Understand, everyone? So you must be able to interpret the graph. It's not that easy, but it's very tricky, but it carries 1 mark question. Okay, so this is part A. Now B, state the time in which she put the vegetable into the pan. This one I already given you some clues just now. Actually, I given you the answer just now. Okay, can you guys type in the group chat what's your answer for B? State the time in which she put the vegetables into the pan. All of you got the answer. Very good. 1 minute, right? Okay, so you just need to state. State means you don't have to explain, you know. Here another problem is that many of you do not understand what the question is asking. State means you just need to state. You don't have to explain. You don't have to waste time to explain. You just state. They say what, state the room temperature. You just state the room temperature. This asks you to state the time. You just state the time. There's no need to explain. Okay, no need to waste time. Okay, then let's take a look at part C. Now part C is the application part. Is the tricky one. Is the challenging one. Okay, but of course you need to use the answers that you have put in part A and B as well as the graph itself. After cooking, she poured the hot oil into the sink. Oil F has a melting point of 40 degrees Celsius. Okay, so let's analyze. First thing they say that oil F has a melting point of 40 degrees Celsius. Then we recall, what does melting means? Melting means the change of state from solid to liquid. So it goes the other way around also. That means from liquid to solid. That means for freezing to take place, it must be at 40 degrees Celsius. That means below 40 degrees Celsius, it will be in solid state. Above 40, it will be liquid state. Correct? Okay, then the question continue. Several months later, the water pipe below the sink was blocked by a solid at X. This one is a very common house problem. So you can see, PSLE, they like to ask you application question. What you experience day to day in the day-to-day situation. Okay, so they ask you to explain why the solid was formed in a water pipe, even though the sink protector prevented the solid waste from entering. Right? So you're asking, how come? Right? Because when we pour the hot oil, the oil is in liquid state. Right? But why is it that when it reaches at this point, there's a choking here? Right? What is the reason? Why this become a solid state? Okay, so this is basically what the question try to ask. Okay, so how to answer this question? Let me share with you the answer. So when poured through the sink protector, the hot oil was in a liquid state, right? Why? You can see the hot oil above 40 degrees Celsius, it is liquid state, right? Okay, so you can see she poured the hot oil. When the oil is hot, it is liquid. So liquid can pass through, right? So the hot oil was in liquid state when the temperature was above the melting point. Then as the oil passed through the water pipe, over time, it will lose heat and freeze into solid state. If you don't put the word freeze also, I think they will accept, right? You can say that it lose heat. Now, lose heat is important. You must mention the keyword, lose heat and freeze into solid state. So it turns into a solid state, right? At room temperature, right? Because remember, you link part C to part A. What is the room temperature? Room temperature is 30, right? So when the room temperature is 30, will the hot oil still be a liquid state? No more, right? Because below 40 degrees Celsius, at 30 degrees Celsius, right, this will be in solid state. So that's why there will be a choking at this part. Okay? Question? Those who have a question, please type in the group chat. I'm going to check your question. Okay, Abdul Martin asks, does that mean that the temperature of the pipe is lower than the melting point of the oil? Now here, you must take note, they are not asking you about the temperature of the water pipe, right? Temperature of the water pipe, it depends on the temperature of the surrounding, right? It is at room temperature as well, okay? Okay, okay, if you say the hot oil was in liquid state, yeah, you need to put that because they say here hot oil, right? Hot oil, it is in liquid state because it is above the melting point. Okay. Okay, Krishan asks, what is the topic for this question? Now, this is the question on heat transfer, right? Heat transfer, you guys learned back in primary 4, as well as on the topic of melting. You guys learned in the topic of water change of state. It's a P4 and P5. It's a combination of topics. In P6, a lot of PSLE question, they combine topics, right? So you need to be familiar with the concept, right? That's why I say that all the concept, it must be at your fingertips by PSLE, yeah? Okay, any more questions? Okay, Raha asks for B. Yes, Raha, what's your question? You can, what do you mean by for B? Oh, if we explain, what if you, oh, Raha asks, okay, somebody asked if in part B you explain, will you lose marks? No, you will not lose marks. But if you explain wrongly, marks may be deducted. They never ask you to explain, they ask you to state. But then you explain, and then your explanation is wrong. The teacher or the examiner may deduct marks for a wrong explanation. Okay, so that's why I read the question very carefully. All right. Hamza asks, is this a P5 topic or P6 topic? Now, this is a P4 and P5 topics, not a P6 topic. This is a P4 and P5 topic. Right? P4 topic on heat transfer and P5 topic on melting or change of state. Okay. Now don't tell me that, Mr. Yang, then how come they test P4, P5 topics? Of course, PSLE covers all topics from P3 to P6. That's why, even though right now, all of you at P6, right, you need to revise on a regular basis, P3 to P5 topics. Because all these topics, you can see so far, majority of the topics that we have discussed comes from, not at P6, most of them is at P3, P4, P5 topics. Okay, let's move on to the next topic. This is another P5, or not even P5. This is a P3 topic on magnets. Okay, on magnets or electromagnet. Okay. Now let's take a look at this question. Let's analyze this question. You guys are familiar with this question, right? Correct or not? You have seen 1 million times, right? So again and again, PSLE comes out again and again on the topic of electromagnet, almost every year. Okay, so by almost every year, students also get wrong. So I don't know why. So make sure you listen and make sure you don't repeat the mistake. All right. Okay, now of course, there's slight variation, but the variation is not that much. But the answering technique or the explanation is the same. Okay, so in the circuit shown below, P and Q are identical bulbs. All the components are working. When switch S is closed, the iron bar moves up and down between point A and B, and the bulbs P turn on and off repeatedly. Now, let's analyze all the keywords. Okay, let's analyze the keyword here. Okay, so they say that when switch S is closed, when it's a closed circuit here, the bulb, the iron bar, this iron bar moves up and down between point A and point B repeatedly. Okay, and then the bulb P turns on and off repeatedly. The bulbs P here, okay, turn on and off repeatedly. All right. So part A, they asked to explain why the iron bar moves between A and B repeatedly. Now, this is a very common question, right? So how to answer this question? All right, later on we will go to it. Then B, state which bulbs are lighted when the iron bar is at point A. So at point A, which bulb is lighted? So this again, state. You can either state the answer is either P only, Q only, or both P and Q. All right? And then C, when the iron bar is at B, state how the brightness of Q changes and explain your answer. Now, part C, there are two parts to the answer. Please take note. Okay, and the marks is also 2 marks. Some students see 2 marks, but your answer is very short. Something is wrong somewhere. Okay, so in this question, why 2 marks? Because there are 2 parts to the answer. Number 1, you need to state how the brightness of the Q changes. That means you need to say whether bulb Q, does the brightness increase, decrease, or remain the same? Right? So that is stating. And then you need to go on to explain. You cannot just state without explanation. If you don't explain, right? So at most, you get half of the mark, but provided your first part is correct. Right? So you need to explain to get the other half of the mark. Okay? Okay, let's take a look at the concepts here. Now, if you recall, right, this is on the topic on 2 topics. One is electromagnets. You guys learned this in primary 3 under the topic of magnets, right? Way back P3, topic of magnets. And at P5, you guys also learn on the topic of electrical system, correct? Again, it's not a P6 topic, but it is tested in the PSLE. Okay, so what is required for you to know? What concept? Number 1, you must know how to make magnets using the electrical method. If you have forgotten, problem. Remember, there's another way to make magnets using stroking method, right? But in this particular question, they're asking you how to make magnets. When they say make magnets, which magnet they're talking about here? This iron cylinder. Iron cylinder here is not a magnet. It is iron, right? How do you magnetize it? How do you make it into a magnet? Okay, so you need to understand this concept. Secondly, the workings of electromagnet. You must understand how electromagnets work. Okay? And part B here, right? What are they asking? You must be able to understand the difference between the closed and open circuit. What is a closed circuit? What is an open circuit? Okay, this one you guys learn in P5 under the topic of electrical system. And part C, what is the concept that you need to know? You need to know or investigate the effects of number of bulbs arranged in series. Right? So meaning, if you put in series, right? If you add more bulbs, what happened to the brightness? If you remove the bulbs, what happened to the brightness of the bulb of the remaining bulbs? Can you remember or not? Remember or not? The effects, so we can see this question, even though it's one question, but it tests multiple concepts, right? So not that easy, okay, but I'm sure you guys can do it. Okay, let's go to the answer itself. Part number A. Part A. So when the switch is closed, the iron bar moves up and down between A and B. Explain why the iron bar moves between A and B repeatedly. Okay, so what's the answer? This one you guys know already. Okay. So when the iron bar is at position A, it forms a closed circuit, right? It forms a closed circuit, causing the iron cylinder to be magnetized. So what do I mean by closed circuit here? Okay, let me just show you the diagram. When the iron bar is at point A here, so it forms a closed circuit. So where's the closed circuit? So when you switch on, right? So this is a closed circuit. Okay, so you can see the current will flow. And what will happen? This iron cylinder will become magnetized. Or if you say become an electromagnet, also no problem. right? I like to use the word magnetize, but if you use the word electromagnet, also no problem. So when this iron cylinder is magnetized, it is going to attract the iron bar to the iron cylinder, right? So this will attract the iron bar to position B, right? So this iron bar will go up from point A to point B. Now, when this happens, it will create a gap. So where's the gap now? The gap will be at this point here. When this iron bar goes up, there's a gap here. When there's a gap, there will be an open circuit. When there's an open circuit, what will happen? Right? When there's an open circuit, the iron cylinder will become demagnetized, right? When it becomes demagnetized, what will happen? It will not be able to attract the iron bar anymore, right? So this iron bar will go back to position A. So you drop back, the iron bar will drop back to position A, and then repeating the process. When it drop back to position A, it becomes a closed circuit again, and then the process will repeat continuously. Okay? Understand our class? Okay, those of you who have any question, please write in the group chat. I can try to answer. Okay, Riz say, what do you mean by metal contact? This is the metal contact here. Metal contact is given here in the diagram here, right? So I'm using the term in the diagram itself, right? Okay, Raha asks, what is demagnetize? Demagnetize is the opposite of magnetize. Demagnetize is when the iron cylinder loses its magnetism. Shabir, you need to put open circuit. Open and closed circuit is a very important concept. Okay. Nurhan says, is this an alarm question? No, this is not an alarm question. Because they never say anything about alarm. But yes, the alarm, the fire alarm uses a similar system. Okay, Qayyum asks, do question always like to test us on electron? Yes, very much. Favorite question, PSLE favorite question. So you must know this at your fingertips. Okay? All right, thank you very much for your question. Those of you got any more questions, just type in the group chat. I try to answer as much as I can. Okay, now let's take a look at part B. State which bulb are lighted when iron bar is at point A. Okay, can you guys type your answer for part B? This one very easy. Just state. Can you tell me, type in the group chat, what is your answer? When the iron bar is at point A. Okay, I can see different answer. Okay. Some of you say P. Many of you say P. Some of you say Q. Some of you say both P and Q. Okay, the answer is both P and Q. Both P and Q. Okay, why? Actually, I draw for you guys already just now. Okay, now let's take a look. Why P and Q? When the iron bar is at point A, now this becomes a closed circuit, right? This switch is closed, so it becomes a closed circuit. So this is the flow of electricity. Can you see the one I highlighted? So the electricity flows this way. So can you see this? This way, right? It goes this way. Can you see that there's a continuous flow of electricity, right? Passing through P and Q. And can you see that this is a closed circuit, right? This will happen only when the iron bar is at point A. When the iron bar is at point A, the gap here is closed, right? Because iron bar is a conductor of electricity, right? So the electricity here becomes there's no gap here. Only when A goes up to B, then there's a gap. It becomes an open circuit. Now there's a closed circuit. So the answer is both P and Q. Okay? Now part C. When the iron bar is at point B, state how the brightness of Q changes. Okay, can you guys type your answer for this one? Just no need to explain. Just tell me what happened. I want to know whether you guys understand this or not. How the brightness of bulb Q changes. Is it increase, decrease, or remain the same? Just tell me increase, decrease, or remain the same. This is a little bit challenging. Many, I can see various answers. Fairly equal response. Many of you put decrease. Many of you put increase. Many of you put remain the same. Okay. Now you can see, PSLE is not easy. Okay, what's the answer? All right. Ali say IDK. Champion. IDK. Okay, the answer is, it will surprise you. Actually, the brightness of bulb Q will increase. The brightness of bulb Q, it will increase. Now, who put increase? Who put increase? Well done. Okay, you put increase, you get 1 mark, right? But you need to explain. The explain part is the tricky part. Okay, why increase? So please listen very carefully. Why increase? Right? So you need to know this. So when the iron bar is at point B, when the iron bar is at point B, now let me put at point B here. Now this becomes a closed circuit. So where is the flow of electricity? The electricity will flow this way. You agree, right? When the iron bar is at point B, this is where the flow of electricity is, right? And it is covering only bulb Q. Bulb P will not be lighted. So now, for the same number of batteries, it only needs to light up 1 bulb. Compare to the previous, when iron bar is at point A, it needs to light up 2 bulbs. And remember, when 2 bulbs in series, the current has to be shared. That's why it is dimmer. But now, when only 1 bulb has to be lighted, the full amount of current will go to Q. So the bulb in Q will be brighter than before. Understand? So I repeat. So number 1, you mentioned that the brightness of Q will increase. So this will get you 1 mark. At point A, bulb P and Q are in series. Hence, the current will be shared between the 2 bulbs. So that's why it becomes dimmer, right? At point B, when it goes to point B, the metal contact at A is open, but closed at B. So B becomes a closed circuit. Hence, no current pass through bulb P, causing higher current to pass through bulb Q. Okay? Question, 12 o'clock already. Okay, give me another half an hour. I know I promise you guys, I forget about the clock. So sorry, because just now I started a bit later because there was still some joining us. I got 2 more questions. I go a little bit quickly. Okay. So maybe I need about half an hour more. Okay, so let me just repeat here. So let's say now there's a 20 units of electricity. This bulb here will also get 20 units of brightness. Okay. Now before that, when the bulb was, when the iron bar was at position A, right, the circuit goes this way, right? When the circuit goes this way, this is 20, so this will be 10 units, and this will be 10 units, right? Because it is in series. Okay? Understand? Okay, Charlize, if you need to go for another class, no problem. You need to go, don't worry, because I record this lesson. Those of you who need to go, so sorry, I delay a little bit. Probably I will need about 20 more minutes to discuss question 39 and question 40. Okay? Okay, now let's take a look at this question very quickly. Now, this is a very interesting question. It involves drawing. Okay, so Kenneth set up an electrical circuit in the toy using identical bulbs and batteries as shown below. All the circuit components are working. When you close the circuit, the bulbs did not light up. The bulbs did not light up, So use a pencil to complete the circuit below. Correct the mistake. It's a 3-mark question. Number 1, you need to correct the mistake. Secondly, you need to connect the bulb such that if one bulb blows, the other will be lit, and the bulb will light up only when the switch is closed. Okay, so this I thought is a very interesting. There was 1 year also, they asked you to draw the circuit in an ambulance. Okay, so you must be prepared to draw circuit diagrams. So this is on the P5 topic on electrical system. Number 1, you must understand the components of electrical system. Every you must know how does the battery works. right? How does the wire works? How does the bulb works? How does the switch works, right? And you must be able to draw simple circuit from circuit diagrams. And then you must be able to differentiate the effects on bulbs arranged in series and in parallel. Okay, and you must know the arrangement of batteries. Okay, so there are different components or different concepts that you need to know, right? So these are the key concepts tested in this question. Okay, so how to draw? Okay, so this is the answer. This answer here. Now let's analyze one by one. Now, first of all, you need to correct the mistake. Now, the first mistake is that you can see this bulb. Sorry, this battery, it is arranged in a wrong manner, opposite manner, right? You know that the positive side must be connected to the negative side of the other battery. Okay, so you need to rearrange it. So you can see here, this is the positive side, the negative side. So the positive side must be connected to the negative side. Okay, so secondly, they say that one blow, the other bulbs will be lit. So we want it to be arranged in parallel. So how to arrange in parallel? Okay, so this is the way for you to arrange in parallel. So the bulb here must be arranged in parallel so that if one blow, the other one will remain light up. Okay, how? Now let me draw for you guys. How does this work? All right, so let me use a green pen now. Okay, so when I turn on the switch, right? Turn on the switch, I close the switch. So you can see here, this is one electrical pathway. This bulb will light up, correct or not? This bulb will light up. At the same time, this bulb will also light up. Can you see that this is a parallel arrangement? So if one of the bulb is fused, now if let's say this is fused, this is broken, right? There is still a continuous flow of electricity to allow this bulb to light up. Likewise, when this bulb is spoiled, this bulb is blown, fused, the electricity can still flow this way. Okay, so that is the way to draw. And then for the second criteria, the bulbs will only light up when the switch is closed. Yes. When the switch is open, there is a gap here. When there's a gap, both bulbs will not light up. Okay? So that is the answer for this question. Okay, any question? Please type in the group chat. Okay, Lily, if you have to go, no worries. Those of you who have to go, not a problem. Anybody have any question regarding this diagram, this question? No, Okay, good. Now let's move on to last question. So last question, part A, they ask you to state what boiling means. State means you just state, right? What is the meaning of boiling? Okay, so this is an application type question. Part A is a simple recall question. Part B is an application question where you need to use the concept from the earlier parts. Okay, so this is an application type question. And what topic is it covering under? Covering under the topic of heat as well as water. Heat, okay, you can see the same year PSLE, a lot of questions involving water. So those of you who wants to focus, please make sure you understand very thoroughly on the topic of water. It's a very huge topic, and they like to ask many questions. And the topic of heat also, favorite PSLE question. Okay, and they like to link this together. Okay, so you must understand the process of boiling, right? What is the meaning of boiling? Boiling is a change of state, right? From liquid to gas. Understand the heat transfer, how heat transfer. And understand that matter gain heat and expand when heated. This one is another thing that you need to know on this question, because they ask you why the glass top cracked, right? You must understand that matter will gain heat and expand when heated. Opposite happen. Opposite, when it loses heat, it will contract. It will contract when it loses heat, right? Okay, let's go straight to the question itself. So part A, what does boiling means? What does boiling means? Okay, let me take out my pen. Okay, so you know from P5, under the topic of water, boiling is the process in which liquid gain heat and change into gaseous state or gas state. It's a change of state from liquid to gas. So these are the keywords that must be part of your answer, as well as this, gain heat. You must, many students, they miss out this part here, gain heat. Okay? Now part B, they ask you, explain. So an engineer wanted to test if the electric pot can be used on a table with a thick glass top. He heated the water in a pot for 1 hour. Explain why part A of the glass top was hotter than part B. Now, part A is close to the pot, but part B is at the edge of the table. Why part A at the top was hotter than B? Okay, how to answer? So we know the concept of heat transfer. How does heat transfer? Heat transfer from region of higher temperature to a lower temperature. So how does heat transfer in this particular question? From hot here to the cooler part, right? This is the heat source, the source of heat. So the heat will travel. The heat doesn't jump up here, right? The heat travels from region of higher temperature to a lower temperature. Okay, so as heat travels from higher to a lower temperature, as part A is nearer to the hot pot or the heat source, it gains heat faster from the hot pot compared to part B, right? So there's the answer for part 1 of question B. Understand, huh? Okay, part 2, they ask you, the glass, this is slightly challenging. The glass top cracked after some time. This is the glass top. How come it cracked? What's the reason? Remember on the topic of heat, right? We learned that metal can expand when heated. So what happens if this glass top is heated on a continuous basis? It will expand, correct or not? But does it expand evenly? Does it expand evenly? No, right? Because the the glass top which is nearer to the pot will expand faster compared to the part at B. Okay? So you need to explain why. So when heated, the glass gain heat and expand. As glass is a poor conductor of heat, some parts of the glass does not expand fast enough, resulting in uneven expansion. So which part is doesn't expand fast enough? Which is the part which is further away, right? So when glass, we know that glass is a poor conductor of heat, so it takes a long while for the heat to travel. So when the heat travels here, so this part here will expand. The part which is nearer to the pot will expand first. So when it expands, it does not expand as much, the part which is further. So that's why this uneven expansion will eventually cause the glass to crack. Okay? All right. Okay, that's all. That's all. Now, those of you who have question, please type in the group chat. You got question on any part of the question so far, please feel free to do so. Okay, Fauzan say, because the pot is heavy with water. No, nothing to do with heavy water. Someone may say, teacher, is it because the pot is too heavy, crack? No. Even though you answer, it is probable, right? But it doesn't answer or it is not linked to the question. You must always link to the concept in the question. Okay? Nurhan say, can we use the word heat insulator? No. Insulator is used for electricity. Electrical insulator means electricity that cannot pass through. Heat, you always use the word either a poor conductor of heat or a good conductor of heat. Okay? All right. Okay, so we have come to the end of today's session. Right? So I would like to thank everyone for joining. Okay, and those of you who will see me in class, I'll see you again, and have a good holiday, and bye-bye everyone.